When it comes to getting the ultimate lap time out of any car, it really comes down to the tyre contact patch between those four tyres and the racetrack that's going to define how much grip is available. Of course, optimising that comes down in a large part to the damper selection and the damper tuning. So we're here with Dejan from TracTive Suspension to find out a little bit more about what goes into that. Now, Dejan, for a start, I really want to talk about the TracTive suspension setup. You're running this in the RP968. It's just become the second fastest car ever to go around Eastern Creek with a 119.2, dangerously close to the outright lap record, and of course the suspension plays a big part in that. So can you just talk us through the TracTive suspension in terms of the damper arrangement that you've got in this car?
So TracTive suspension has a proprietary valve. It's called a DDA valve, and basically they are electronically variable. So the damping is not just like a normal construction. It has a valve inside which helps vary the flow. So if you looked at it from the outside, you wouldn't be able to tell that it's an electronic shock because it looks the same. Most of the construction is the same. We've got a piston, shim stack, gas pressure, canister, etc. But behind the piston is a little solenoid, and that solenoid can open and close 160 times a second and stop anywhere in between. So we can vary the current, which varies the damping rate, anywhere every 6 milliseconds.
Okay, so basically what you're talking about there is the ability to actively change the bump and rebound damping on the fly as the car goes around the track. Now, let's just take it back a little bit, dumb it down a little bit, and for those who aren't really aware of how that valving plays a part in the motion of the damper, can you sort of talk us through that?
So the damper curve or the valving is speed dependent. So the force, the resistance that the damper provides in its ability to control both the wheel, what I call wheel control, and the body. So in fact, the damper is probably one of the most important elements on the car, which has lots of variable jobs. So in the shape of the curve, we have a bleed rate, we have a transition, we have a high speed rate, and so the damper then has to control various aspects and the various forces that are coming through it.
So in rough terms there, we're talking about the fact that depending on the speed the damper's moving, so for example, as the driver turns the wheel and the car tends to try and roll over, the damper is in charge of controlling that motion, so relatively low speed. Then you've got undulations in the road, which are a higher speed, and then of course if the driver runs a ripple strip or something like that, there's an instant shock and the damper needs to bleed off very quickly. All of that needs to be optimized in order to keep the contact patch of the tyre optimized?
Yeah, that's correct. And most passive dampers, most normal dampers these days have special valves, they have special pistons, they have shim stacks that are preloaded. So internally their constructions are quite good. And we can get, like, you see most of the cars around here get pretty good lap times. But when it comes to maintaining and maximizing the grip of the contact patch and maximizing the aero platform, having a variable damping means that you can optimize different parts of the curve for different parts of the track.
All right, so your TracTive dampers that are in the RP968, you've still got an external reservoir with what looks on the face value to be a conventional adjustment for bump and rebound.
Right.
So that works in conjunction with the electronic valve?
Exactly. So the electronic valve is basically like an overall damper. So you could buy TracTive shocks without the canisters, and you just have the valve internally. And then it would just operate just like a normal bypass valve, but electronically. We add the canisters so that we can get more bump and rebound variation. So, for example, if you have really bumpy circuits or road that you're running on, you can then fine-tune the compression resistors, the bump, high speed and low speed, so that it's tailored to that. However, the valve, it predominantly will do a lot more of the body control, but we also know how to vary it so we can get better wheel control as well.
So could we sort of break that down and consider the manual adjustment for bump and rebound as a course adjustment to get in the ballpark, and then the electronic valving is fine-tuning within that?
It's like fine-tuning. So here we're pretty much heaved into bump rubbers most of the way around the circuit, and we tune our bump rubber stiffness and our packers, but then we tune our high-speed and low-speed compression so we can get the feed into those bump rubbers nice and smooth. So you can do that with the valve, but the best thing about it is that you can do it externally too, so that there's the cars coming along. And the benefit of that is that we've also got shim stack blow off, we've got the canister, and we can adjust the gas pressure as well. So there's a lot of variations that we can do. For a lot of the people that play with shock absorbers, they probably don't even know what high speed and low speed can do for them. For those people that do, see the benefits of having canisters, and then on top of that, now you can put an electronic valve. So you've got a whole range that you're just basically pushing the damper to a bigger window.
Now, I just want to go back and unpack something you just mentioned there. You said about running down onto the bump rubbers, and this is a problem we see with cars with a lot of downforce. Basically, at very high speeds, they're producing so much downforce that the car is physically being pushed down onto the ground. So you compromise, either you run a very high spring rate so that the car doesn't do that, but that then compromises the low speed cornering performance. So the bump rubber is a decision you make to sort of compromise that whole setup.
Yeah. So a normal spring arrangement, your resistance is a linear function of your displacement. So what we do now with these cars, and a lot of people do it, it's not new technology, is that we run some preload on the springs, okay, and that lifts the curve up. Then we have a linear spring which is quite firm still, because we don't keep them soft, because if you have it soft, then the unloaded side lifts. So you need to manage the inside as well as the outside. And then you introduce your bump rubbers, and they have to be quite progressive. So you have this curve, which is now, used to be a straight line, but now it's got a step, a ramp, and a curve. And we want to operate in that window, so our energy absorption is managed. We get the right amount of energy absorption, the right end point, and so that the balance then comes that the shock is basically holding the car, but not disturbing it and causing it to bump.
All right, so getting down a little deeper into the electronic valving as well. So you've got some quite flash functionality around this in terms of the way the driver can then control or adjust the damping on the fly to suit his preferences. So you've got, I think you said, 5 stages of adjustment for that?
In the basic setup of the TCU, we can provide a driver with 5 adjustments. That's the most basic, and we can pre-program those 5 with a range of input variables. We can also have, especially for street car users, because we do have a street car range, a touchscreen display, and then they can choose roll and pitch and heave independently. So, but in a race car application, we tend to like to put just 5 modes for the driver, and something like a wtac dash could do this, where it can send via CAN a signal and say select mode 1. And the driver could do that, or it could say, okay, select mode 2. And so the benefit then is that we can have an external device that can also select the modes for us. So it's not just a driver selection. Currently, we're just doing a driver selection. Today, that's all we've been doing, because we've been fine-tuning bits and pieces of it. But you can have an electronic device like a wtac that will look at variables like lap distance, vertical Gs in the chassis, or GPS, whatever you want.
So that leads me to that next part, which is really quite an exciting aspect of it, because of course, depending on the particular area of the track, the speed, whether the track's bumpy or smooth in that area, you may actually get better performance with a particular damping profile. So as you just mentioned there, if you're looking at something like lap distance, you could then use the lap distance output from the wtac dash, or any dash for that matter, to then alter the damping profile for different parts of the track.
Yeah, and we were running that last year. We had, we knew what we wanted turn 1, we knew what we wanted. So when lap distance was 600 meters and then 700 and 800, and we were switching between modes. It sort of gets a little bit confusing for the driver, and it gets a little bit confusing for the engineer as well, because you have to look back and say, where were we? And especially if you transition from one mode to another.
All right, look, Dejan, it's a really interesting technology, and obviously working incredibly well here on the RP968. Thanks for the chat, and if our viewers do want to find out more about TracTive suspension, where can they go to?
So obviously they can go to tractivesuspension.com, and us as the Australian and New Zealand distributor, they can go to ttsuspension.com.
Perfect, thanks a lot.
Yeah, thanks a lot.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.